All right, we are on page 615. We are on Unit 7, Lesson 3, powers of tens. So we'll have a power of 10 raised to a power. What is the volume of a giant cube that measures 10,000 kilometers on each side? Remember, volume is your side cubed. So our side length is 10,000 to the power of 3. So if we go ahead, we can keep it at that. Way nicer than all the zeros we're about to get. Oh, we actually aren't going to get that many powers. We are going to get 10 to the power of 12. 1 to the power times 10. 1 times 10 to the power of 12. That's going to give us 10 with 12 zeros. So these two would be the more scientific or shorter way to write it. So raising powers of 10 to another power. So for the first one, we have 10 to the power of 3 times the power of 2, or raised to the power of 2. If we were to write it in expanded form, we write our first thing, which is 10 to the power of 3, and we're going to write it 2 times. So there's 1, there's 2. Wrote it 1 time, wrote it 2 times. Since it's multiplying, we can then rewrite it to a single power of 10. We have 1, 2, 3, 4, 5, 6. So 10 to the power of 6. The next one we have 10 to the power of 2, which is right there. And we wrote it 5 times. So 1, 2, 3, 4, 5. We now have 10 to the power 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So looking at just these two, we ended up multiplying our powers. So 3 times 2 gives us 6. 2 times 5 gives us our power of 10. This next one, our first set inside parentheses, is 10 to the power of 3. And it was written 1, 2, 3, 4 times. So we're going to raise that to the power of 4. 3 times 4 is 12. So I have 10 to the power of 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Next we have 10 to the power of 4, and we're going to do it 2 times. So that's 10 to the power of 4, and we're going to do it again. Which gives us 1 set, 2 sets, and we now have 10 to the power of 8. 2 times 4 is 8. The next one, 10 to the power of 8 raised to the power of 11. We would then write this that 11 more times, which we're not going to do. That's just ridiculous. That would take up the rest of my paper. We're not having these. So we're going to skip this part, and we're going to use the rule. When you have 10 to a power raised to another power, you multiply them. So we have 10 to the 88th power. We're not going to write 10 times 10 88 times. Seems ridiculous. If you choose to skip one entry on the table, which entry did you skip? Well, we skipped 10 to the power of 8 raised to the power 11 because that would be writing 10 times 10 88 times. Use the pattern you found in the table to rewrite 10 to the mth power raised to the nth power as an equivalent expression to a single exponent. Well, up here we were multiplying our exponents, so that's what we're going to do here. We're going to have 10 raised to the m times n power. Next page. If you took the amount of oil consumed in 2 months in 2013 worldwide, you would make a cube of oil that measures 10 to the power of 3 meters on each side. How many cubic meters would this be? So to find volume, we cube it. So each side is already this. That's what each side was. And to find volume, we need to cube it because each side length is the same. How many cubic meters of oil is this? Do you think it would be enough to fill a pond, a lake, or an ocean? So if we're going to find this as a single power, it is equal to 10. We have 3 times 3 raised to the 9th power. Well, 10 to the 9th power is 100,000 millions, billions. 1 billion cubic meters. Is that enough to fill a pond, a lake, or an ocean? Probably. Let's think about it. Activity 3.3. How do the rules work? Andre and Elena want to write 10 squared times 10 squared times 10 squared as a single exponent. Andre says when you multiply powers with the same base, it just means you add the exponents. So 10 squared times 10 squared times 10 squared is 10 to the power of 2 plus 2 plus 2, which is 10 to the power of 6. Elena says 10 squared multiplied by itself 3 times. So it would be 10 to the power of 2 times 10 to the power of 2 times 10 to the power of is equal to 10 to the power of 2 raised to the power of 3, which equals 10 raised to the power of 2 plus 3. So 5m. Do you agree with either of them? Explain your reasoning. Well, both of them have the right idea. We agree with Andre because with the same base means you add your exponents. So 2 plus 2 plus 2 is indeed 6. And we agree with Elena, but only till here. All of this is correct. But earlier in this lesson, when we have a power raised to another power, we need to multiply them. So this should be 10 to the power of 2 times 3, which gives us 10 to the power of 6. So we agree with Andre. From start to finish. Finish. And we agree with Elena until 10 to the power of 2 cubed, because she should multiply powers, or she needs to multiply. Multiply powers, not add. Summary. In this lesson, we developed a rule for taking power of 10 to another power. Taking a power 10 and raising it to another power is the same as multiplying exponents. So we need to multiply exponents. See what is happening. So we have 10 to the power of 4. And they didn't expand it in this one, probably due to space. It is the same as 10 to the power of 12. Well, we have 3 times 4 which is 12. This works for any powers of 10. So if I have 10 raised to the 6th power raised to the 11th power, instead of writing 10 times 10 times 10 times 10 times 10 times 10, 11 times, we would multiply our exponents, giving us 6 times 11, which is 66. Next page, 617, practice problems. Rewrite the expressions as a single exponent. So we have 10 to the power of 7 raised to the power of 2. Well, if we multiply our exponents, we now have 10 to the power of 7 times 2, which gives us 10 to the power of 14. Next, we have 10 raised to the power of 9 times the power, or raised to the power of 3. So we have 10 and then 9 times 3, so 10 to the 27th power. See? 10 to the power of 6 times 3 gives you 10 to some power. Try D, E, and F all on your own. Number 2, if you have 1,000,000 number cubes, each one measuring 1 inch on a side, if you stack the number cubes on top of each other to make an enormous tower, how high would they reach? So we have 1,000,000 number cubes. They're each 1 inch tall. So 1 inch times how many cubes we have? We have 1,000,000. Whoops. How tall would they reach? Well, they would reach 1,000,000 inches tall, which is the same as 1, or you can do 10 to the power of 6, or 1 times 10 to the power of 6, which gives you 10 to the power of 6 inches tall. If you arrange the cubes on the floor to make a square, would the square fit in your classroom? What would its dimensions be? Explain your reasoning. So we need to make a square. We have 1,000,000 cubes. Excuse me. So our area would be 1,000,000. So something times something is going to give us our 1,000,000 cubes. Well, if we were to do the square root, we would see that 1,000 times 1,000 gives us. So would the square fit in your classroom? Well, 1,000 inches. Let's see how many feet that is. There's 12 inches in a foot, so we have 1,000 divided by 12. So just over 83 feet. I believe that is bigger than our classroom. Our classroom is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Each of these squares look like they're about 2 feet. So our classroom, I'm guessing, is about 32 feet long, which is less than 83. If you layered the cubes to make one big cube, what would the dimensions of the cube be? So now we have a cube. So we need to figure out something times something times something equals 1,000,000. So to find that out, we would have the cube root of 1,000,000, but powers of 10s we kind of know. So 10 to the power of 3 is 1,000. 100 to the power of 2 is 1,000. 100 to the power of 3 is 1,000,000. So that means each of these would be 100 inches. 100 inches. 100 cubed equals 1 million. And we just did that knowing that our volume would be 1 million because that's what our cubes are. Review of lesson 1. The ambula divides to form 2 ambulas after 1 hour. 1 hour later, each of the 2 divide into 2 more. Every hour, they divide to form 2 more. So, they start with 1. 1 hour later, there's 2. 2 hours after that, each one of those divide into 2. So I start with 2, and now I have 2, and I have 2, so I have 4. Write an expression for the number of ambulas after 6 hours. I'm sorry, they start with 2 after an hour. So I start with 2 every time for this. 2, 2. And then how many hours later? Well, this is 2 to the power of 2. So after 6 hours, it would be 2 to the power of 6, which equals 2 to the power of 6 is 64. Write an expression for the number of amebas. I don't know. After 24 hours. 2 to the 24th power. What would it be? What might the exponential notation be preferred to the answer of these questions? So we're going to be getting bigger. So we're going to have 2 raised to x power. Number 4 is a review from Unit 4. Elena notices 9 years ago, her cousin Katie was twice as old as Elena was then. Then Elena says, in 4 years, I'll be old as Kate is now. So Kate was twice as old than Elena 9 years ago. In 4 years, I'll be as old as Kate is now. So Elena plus 4 is going to equal Kate. Because that's just this one. 4 years, she'll be as old as Kate. So Elena plus 4 is Kate. So it might be A. E plus 4 is Kate plus 4. No. And this one. Okay. The other part. 9 years ago, her cousin Kate was twice as old as Elena is now. So we're going to be 9 years ago is taking away. So both of these take away. So this is saying Kate minus 9 is equal to Elena, 2 of Elena's age now. But remember, this statement is all about 9 years ago. So we also have to take 9 years away from Elena, which would give us D. And that is your Unit 7 Lesson 4 video.